Welcome to solverfy.
Okay, so this is the free body diagram for the block E. So for block E, you should experience two tensions point downward, okay, from the pulley, and the normal force point upward, and the friction along the surface, and the tension with the angle theta here, okay. And since the block E is not moving, that means the block E is in equilibrium, which means that the net force on block E along the x direction and the y direction should be equal to 0, okay. So now since there's the angle theta here, let's decompose the tension here. So we'll have T cosine theta point downward, which is the y components of the tension here, and the x component of such tension is T sine theta. So therefore, we know that the net force along the x direction is equal to 0. So we have T sine theta minus F is equal to 0. Okay, so eventually we have T sine theta is equal to F. So we know friction, which is the static friction in this case, is equal to mu s n. Okay, we'll wait here. Okay, because we need to substitute something for normal force later. So we know the net force along the y direction is equal to 0 as well, since it's in equilibrium. Okay, so we have normal force n minus 2t minus t cosine theta is equal to 0. Okay, so therefore n is equal to 2t plus t cosine theta. So now we can plug in back to the equation for the normal force. Okay, so eventually we have the friction is equal to mu s times 2t plus t cosine theta. So we'll have t sine theta is equal to mu s, and which is 2t plus t cosine theta. As you can tell, t can be cancelled out. So eventually we have sine theta is equal to mu s times 2 plus cosine theta. And we know mu s, which is the coefficient of static friction, is 0.35. So therefore, if we plug in, we have sine theta is equal to 0.35 times 2 plus cosine theta, which is equal to 0.7 plus 0.35 cosine theta. Then we could put a square on each side. And eventually we have sine square is equal to 0.4 plus 0.35 cosine theta square. And then we expand it, we'll have 0.49 plus 0.49 cosine square theta plus 0.1225 cosine square theta on the right side. And on the left side, we have 1 minus cosine theta square. Okay, since sine theta square is equal to 1 minus cosine theta square. So therefore, eventually we have 1.1225 cosine square theta plus 0.49 cosine theta minus 0.51 is equal to 0. So now we can apply the equation or the formula to determine cosine theta. So the cosine theta is equal to negative 0.49 plus minus square root 0.49 square plus 4 times 1.1225 times 0.51 over 2 times 1.1225. So eventually we have cosine theta 1, which is the first solution here, should be equal to 0.49. And the second solution should be negative 0.93. So now we can determine these two angles. So theta 1 is equal to inverse cosine function, which is cosine to the power negative 1, and what's inside is 0.49. And this will give us the angle is about 60.66 degree. For theta 2, we'll have inverse cosine function, and what's inside is negative 0.93. And this will give us the angle is about 158.44 degree. Okay, but if you take a look at the graph from the book, from the question, you can tell that the angle theta is less than 90 degree, which means that the only plausible solutions from these two solutions here is theta 1, because theta 1 is less than 90 degrees. Okay, so therefore the angle should be equal to theta 1, which is 60.66 degree. Okay, so therefore the maximum allowable value of theta is 60.66 degree. And this is the answer for this question.